Hello everybody and welcome to the NEPSI Tech Talk session 51. My name is John Steciuk. I'm the Automation and Controls Engineer for NEPSI. Today our topic is capturing and reviewing event data. We'll be talking about the benefits and the purpose for event reporting. And we're going to be talking about some applications that event reporting is useful. We're going to go through some configuration with an SEL 751 relay, and we're going to retrieve and review some event reports. As I go through the session, if you have questions, you can type them into the chat box. If you're looking for PDH credits, send me an email and provide the confirmation code that we're going to give at the end of the session, and we'll get you your certificate. If you have recommendations for future topics or guests, then you can also send us an email. Alright, so we'll get into it. Event reporting. So what's the point of doing all this? Well, the way I see it, since we've had electrical systems around, there's always been failures on electrical systems, and it leaves management asking why. How did this happen? Failures can result from very minor issues to up to ranging to loss of life or injury of workers, loss of equipment, and plant downtime. So it's really important that we can prevent future failures on electrical systems. Some of the ways that people are doing that now are with routine maintenance and changing out old parts, but you can't always foresee a failure, especially if you have some kind of environmental factor like storms, lightning strikes, animal interference, things of that nature. You can have human error, misoperation of equipment that result in failures, and so event reporting is going to help us answer the question, how did this happen? And the cause of the failure, even with event reporting, isn't always obvious, but the benefit is that event reports provide a clear record of measurements and the status of inputs and outputs at the time of interest. So if you combine that with other factors surrounding the failure, then it might help the user guide the user to the root cause of the failure. So in summary, event reports are a record of data that's taken during the time of a system disruption or event. And event captures can be triggered by analog or digital set points, or you can trigger an event report on demand. The reports contain a wide range of analog and digital data presented in a way that's easy to read and interpret. So you can present this information to management and help answer their questions. Alright, so how can we capture event data? Well, most modern protection relays have the capability of capturing some type of event records, and it's really important to get to know the protection relays that are used at your plant, get to know the software and how to set it. A good way to do that is to read the instruction manual. I always find that any relay that's worth its weight will have a very thorough instruction manual, and it will describe all the capabilities and how to use the relay. So that's a good starting point. And another good way is to take a class from the relay manufacturer. Sometimes there's free web-based training or for a small fee. And in-person training I think is great. Usually they charge a bit more for that, but you get to ask all the questions you want, and the manufacturer is the expert on their equipment, so you can expect to get good information from them. Once you're comfortable with your relay and how to use it, you got to decide what data you want to capture, which measurements, current, voltage, harmonics, status of some of your equipment, whether a breaker or fuse operated, and you want to know, what shut down, what turned on, what was going on, and so you want to factor that into your configuration. Some other points, you need to decide how long your record's going to be. You can specify pre-fault length and after the fault length of the event capture, and some relays allow you to choose a resolution for the event, like how many samples per cycle are going to be recorded. Some don't have that feature. Another great one is setting up automatic reporting. Allows you to get an email or a text notification when there's been an event. Alright, so many times event reporting is used to capture data surrounding an electrical fault. It's used as part of the protection scheme in industrial equipment. So you can capture waveforms during overcurrent and overvoltage conditions. Can be configured on feeders or individual loads. Many times the trigger's set up on protection set point, like an overcurrent or an overvoltage or undervoltage or a high harmonic value. And as you can see in the image to the right here, we've got pre-fault values, pre-fault data to the left side of the red dashed line, and then that dashed line represents the event, and we've got, after the event, there's data. You can see the current spikes enormously high. So another type of event reporting, specifically in the SEL relays, is a sequence of events reports. The sequence of events detects changes in the status of digital inputs, outputs, and internal data bits, provides a record of status changes from true to false or false to true. And you can configure which points you want to record. You can exclude points if they're chattering or operating more than expected, filling up your log. And all these points are time-stamped so you can see exactly when they happened. It's pretty useful when you're troubleshooting during commissioning or any other point. Alright, so what I want to do now is take you through the configuration of an event report and sequence of event report settings, and take a look at load profile settings for an SEL 751 relay. So to do that, I'm using this SEL Accelerator Quickset software, which is Schweitzer's setting software. And going to be zooming in from time to time so that it's more clear what I'm doing here. But I'm connected to this relay 751, and looking at the report settings under SER for sequence of event. The first setting in here is chatter criteria. We have trigger lists and relay word bit aliases. I'm going to start out with trigger lists because this is where you define which points you want to record the status of. So it's pretty simple. You select from this drop-down menu the data points that you want, and it shows what you selected over here, so you can either double-click or highlight a group and push the arrow to bring it over. Once you click OK, all of your points are shown in the SER. There's 4 different SERs available, and you can put up to 24 relay word bits per SER. So I'll just quickly show you what an SER report looks like. So using the SEL terminal, I'm going to log in quick. And then you just type the command SER, and it's going to take whatever points you have in this SER trigger list, and it shows you when they were asserted, deasserted, pick up, drop out. So it's pretty useful if you want to see what happened and in what order it happened. The other settings in the SER category are chatter criteria. This allows you to remove a value from the trigger list based on the amount of assertions or deassertions over a certain period of time. So in this example, if a value has changed 10 times within 3 seconds, then it's going to be automatically removed from this trigger list to prevent filling up your log with just that one bit status. And then under aliases, if you don't want to see the SEL relay element names, you can change them here. You specify the relay element and then the alias that you want to use, and then what you want the message to be on assertion and then on deassertion. So you can customize it a bit there. Alright, so let's take a look at the event report settings. They're pretty simple. If you click on the ellipsis, you can see the setting field here, and down below you've got the available relay word bits or analog quantities that you can log in an event, you can use to trigger an event report. So right now we have a list with pickup values for inverse time over current, inverse time residual over current, and some pickup values for instantaneous over current, and some others. I also have one for push button 1. So depressing the push button on the front of the meter will allow you to trigger an event report. There are also menus in the SEL relay that allow you just to trigger an event report there. So if you wanted to trigger something on demand, that's how you would do that. The next setting is the length of event report, and you can choose either 15, 64, or 180 cycles. And after that, we have the pre-fault length. You can specify anywhere from 1 to 59 cycles to record pre-fault data. So there's some other settings that you can go through in the reports section. This is high impedance fault event reporting that you can enable, and they have some fast message read features. But I want to get into the load profile settings quickly because I find this useful from time to time. There's a load profile list where you can again specify different values to log analog quantities at different intervals. This is more for like long-term logging. The intervals for acquisition rate are 5 minutes, 10 minutes, 15, 30, and 60 minutes. So you can look at the load profile report, and you can export that data into Excel, and you can chart different analog values, and it's very useful for long-term trending. All right, so those are really the main settings that you want to look at for this particular relay. I do want to just mention on the event reports section, I know SEL has some other relays where you can specify samples per cycle. I know that 487V allows you to do that. So you might find particular relays give you some more options. Alright, so next I want to show you guys how to retrieve event reports from this relay. And that's pretty simple too. What you want to do is go up to the top banner and select Tools, go to Events, and Get Event Files. I already have that window open, so it's grayed out. But this is what it looks like when you open it. And you're going to go to it's going to go to the relay and find any events that are in the relay's memory. And that takes just a moment to get the information from the relay. Then you can select the event report that you want and also the type of file you want. I'm going to choose the 32 samples per cycle and click Get Selected Events. Brings you up to a page where you can name the file, choose the save location. You can use default naming or custom naming and change it all right here. Then you click Save, and it takes a minute to get the event report. It takes quite a bit longer if you're using the SEL serial cable. So I recommend if you're doing this, try and use an Ethernet cable. It'll save you a little bit of time, especially if you're getting multiple event reports. I mean, it could take up to a half hour, to get 10 of these downloaded with a serial cable. But that's it. Then your file saves in the location that you specified, and you can go to look at it. One way you can do that is by going to Tools, Events, View Event Files with SynchroWave Event, and that's SEL's software for viewing their event files. I think it's a pretty good piece of software. So I'm going to bring up a few events that I have saved over the past years. The first one is just a general trip. We've had, equipment is running, and for one reason or another, overcurrent or over voltage, the equipment tripped off. So on the top section, we've got the current values. In the center, we've got voltage in kV. And this software allows you to select different quantities and add different charts. I can add a chart that shows the frequency, or I can look at phasor diagrams and just add different data values here. So it's pretty cool software. You can play around with it, and there's a lot you can do. But you can see this event picked up where this red line is, and in the trip bit asserts at this point. So we've got several cycles of pre-fault data, and you can see the current shut off when the equipment does. So not much going on this event, but let's take a look at another one. Alright, so this one we have a phase to ground fault, and I'm going to zoom in a little bit on the event here. You can see we got C phase current is amplified and up to about 15,000 amps. It's real simple to see that at which phase and you know how high the current had gotten. You can add different values here to see other analog data. Alright, I got a couple more events for you guys to look at. The next one is a phase to phase. Take just 1 second to get that up here. And we just have current up on this one. You can see it started out with A phase getting a little squirrely, and then we had C phase join in on the fun. We had a few alarms pick up here: neutral over current, neutral time over current, and time over current. So it gives you a pretty good picture of what happened. Maybe not the cause, but it lets you, at least gives you a place to start investigating. So this next one is an event report where we have that one doesn't want to come up. All right. Got a couple more event reports I want to show you, but I wanted to hit one more slide first here. NEPSI has a product called the Activar, and that's used to assist with motor starts. So we were able to use event reporting to fine-tune the operation of our Activar equipment. The way the Activar works is when the motor is started, our equipment turns on a chunk of capacitance in order to help support the voltage on the system. When the motor starts, the voltage is reduced significantly, and we time our closing of the capacitor stages with the motor start. Once the voltage starts to reach the normal range again, we shut off our capacitors one step at a time, and that keeps the voltage from overshooting, and try to keep the voltage in an acceptable range for the whole motor start. And like I said, we have event reports that we had used to help fine-tune both on the front end and the back end with the timing. So we take a snapshot of the pre-start voltage, and when the motor starts, our capacitor stages turn on. So the voltage recovers quite a bit right away, and as the motor ramps up and slightly exceeds the pre-start voltage, that's when we kick our capacitor stages off. the motor continues to ramp up again. We slightly pass the pre-start voltage and kick the next stage off based on, the third stage is kicked off based on a short timer. And then the motor continues to ramp up and the voltage recovers eventually. So then what we wanted to do on this one was to adjust the timing on the back end to allow the voltage to slightly overshoot on the tail end. So we made our adjustments with the timing and the logic, and took another event report. And here's the results of that. We delayed a little bit longer to shut off the third stage of capacitance, and better results for the customer. So another useful application for event reporting. And that's about all I wanted to talk about today. I know you guys might have some questions for me, so I'll stick around for a few minutes and see if you do. If not, I appreciate you guys taking the time to get on and watch this tech talk, and I want to give you the code for PDH credits is 2181. So if you want to send me an email with that code and just let us know you want a certificate, then we will give that to you. And I look forward to talking to you guys again sometime soon. So leave me your questions in the chat and I will answer. Alright, well, it appears you guys don't have any questions for me, so I'm going to end the session. But again, thank you, and the code for PDH 2181. right, have a great weekend.